Welcome to the presentation on ordering numbers. Let's get started with some problems, and I think as we go through the examples, hopefully you'll understand how to do these problems. So let's see. The first set of numbers that we have to order is 35.7%, 108.1%, 0.5, 13 over 93, and 1 and 7/68. So let's do this problem. So the important thing to remember whenever you're doing this type of ordering of numbers is to realize that these are all just different ways to represent. These are all a percent or a decimal or a fraction or mixed numbers are all just different ways of representing numbers. And it's very hard to compare when you just look at it like this. So what I like to do is I like to convert them all to decimals. But there could be someone who likes to convert them all to percentages or convert them all to fractions and then compare. But I always find decimals to be the easiest way to compare. So let's start with this 35.7%. Let's turn this into a decimal. Well, the easiest thing to remember is if you have a percent, you just get rid of the percent sign and put it over 100. So 35.7% is the same thing as 35.7 over 100. Like 5%, that's the same thing as 5 over 100. Or 50% is just the same thing as 50 over 100. So 35.7 over 100, well, that just equals 0.357. If this got you a little confused, another way to think about percentage points is if I write 35.7%, all you have to do is get rid of the percent sign and move the decimal to the left 2 spaces, and it becomes 0.357. Let me give you a couple of more examples down here. Let's say I had 5%. That is the same thing as 5 over 100. Or if you do the decimal technique, 5%, you could just move the decimal. You get rid of the percent, and you move the decimal over 1 and 2, and you put a 0 here. And it's 0.05. And that's the same thing as 0.05. And you also know that 0.05 and 5 over 100 are the same thing. So let's get back to the problem. I hope that distraction didn't distract you too much. Let me scratch out all this. So 35.7% is equal to 0.357. Similarly, 108.1%, let's do the technique where we just get rid of the percent and move the decimal space over 1, 2 spaces to the left. So then that equals 1.081. So we already know that this is smaller than this. Well, the next one is easy. It's already in decimal form. 0.5 is just going to be equal to 0.5. Now, 13 over 93. To convert a fraction into a decimal, we just take the denominator and divide it into the numerator. So let's do that. 93 goes into 13. Goes into 13. Well, we know it goes into 13 0 times, right? So let's add a decimal point here. So how many times does 93 go into 130? Well, it goes into it 1 time. 1 times 93 is 93. It becomes a 10. That becomes a 2. And later we're going to borrow, so we get 37. Bring down a 0. So 93 goes into 370. I think let's see, 4 times 93 would be 360. It'd be 372. So it actually goes into it only 3 times. 3 times. 3 times 3 is 9. 3 times 9 is 27. 27. So this equals, let's see, this equals, if we say that this 0 becomes a 10, this becomes a 16, this becomes a 2, 81. And then we say how many times does 93 go into 810? It goes roughly 8 times. And we could actually keep going, but for the sake of comparing these numbers, we've already gotten to a pretty good level of accuracy. So let's just stop this problem here, because the decimal numbers could keep going on. But for the sake of comparison, I think we've already got a good sense of what this decimal looks like. It's 1.138, and then it'll just keep going. So let's write that down. And then finally, we have this mixed number here. And let me erase some of my work, because I don't want to confuse you. Actually, let me keep it the way it is right now. So there's two ways. The easiest way to convert a mixed number into a decimal is to just say, okay, this is 1, and then some fraction that's less than 1. Or we could convert it to a fraction, an improper fraction, like, oh, actually there are no improper fractions here. But let's do it that way. Let's convert it to an improper fraction and then convert that into a decimal. So 1 and actually I think I'm going to need more space. So let me clean up this a little bit. There. I have a little more space to work with now. So 1 and 7/68. So to go from a mixed number to an improper fraction, what you do is you take the 68 times 1 and add it to the numerator here. And why does this make sense? Because this is the same thing as 1 plus 7/68, right? 1 and 7/68 is the same thing as 1 plus 7/68. And that's the same thing, as you know from the fractions module, as 68/68 plus 7/68. And that's the same thing as 68 plus 7 is 75/68. So 1 and 7/68 is equal to 75/68. And now we convert this to a decimal using the technique we did for 13/93. So we say, let me get some space. So we say 68 goes into 75. I have a suspicion I'm going to run out of space. But 68 goes into 75 one time. 1 times 68 is 68. 75 minus 68 is 7. Bring down the 0. Actually, you don't have to write the decimal there. 68 goes into, ignore that decimal. 68 goes into 70 one time. 1 times 68 is 68. 70 minus 68 is 2. Bring down another 0. 68 goes into 20 0 times. And the problem's going to keep going on. So, but I think we've already, once again, gotten to enough accuracy that we can compare. So 1 and 7/68, we've now figured out, is equal to 1.10. And if we kept dividing, we'll keep getting more decimals of accuracy. But I think we're now ready to compare. So all of these numbers, I just rewrote them as decimals. So 35.7% is 0.357. 108.1%, and ignore this for now, because we just use that to do the work. It's 108.1% is equal to 1.081. 0.5 is 0.5. 13/93 is 0.138. And 1 and 7/68 is 1.10, and it'll keep going on. So what's the smallest? So the smallest is the smallest is right here. So this is, I'm going to rank them from smallest to largest. So the smallest is 0.138. Then the next largest is going to be 0.357, right? Then the next largest is going to be 0.5. Then you're going to have 1.08. And then you're going to have 1 and 7/68. So hopefully, well, actually, I'm going to do more examples of this. But for this video, I think this is the only one I have time for. But hopefully this gives you a sense of doing these problems. I always find it easier to go into the decimal mode to compare. And actually, the hints on the module do the same for you. But I think you're ready, at least now, to try the problems. If you're not, if you want to see other examples, you might just want to either rewatch this video or I might record some more videos with more examples right now. Anyway, have fun.